Our goal today is to learn how to solve quadratic equations by factoring. What you saw yesterday was how to solve by graphing. So we use Desmos. If I enter this equation, I can graph my parabola. I can find the roots or solutions or zeros. But what we want to do is kind of explore another method using something we'd studied in the previous chapter. I prefer personally the Xbox method when I'm trying to factor. If you prefer the area model that we'd looked at later on, whatever you want to do for factoring. The main difference here is that we had previously only been focusing on an expression. Now we're always going to set equal to 0. So let's say I had started with x squared plus 10x equals negative 21. My first step is going to be to make sure that I'm canceling things out and I'm working with equals 0. So that's a little bit of an aside. My goal to start is going to be to factor this trinomial. As a reminder for my Xbox, I want the top value to always multiply to the product of A and C. In this case, since A is 1, I'm looking for it to multiply to 21 and to add up to B. I want values that add up to 10. So I could go through all the factors. I could think about what multiplies to 21, which is more helpful probably than what adds up to 10, because I'm pretty quickly going to land on 7 and 3. I could use that to split up my middle term, x squared plus 7x plus 3x plus 21, and I'll keep the equal 0. Next, I'm grouping first half and second half. My GCF is x. I'm looking at x plus 7. In the second half, I can factor out a GCF of 3. I'm still looking at x plus 7, and that'll equal 0. My goal here being that these binomials are the same. That's what allows me to take these coefficients and regroup them. So now I have x plus 3 times the quantity of x plus 7 equals 0, and it's factored. Up next, what we're going to use is something new, something called the zero product property. What that essentially says is that if two things multiply to equal 0, one or both of them has to be 0. If I said A times B, I have two values and I know that they equal 0, A could be 0 or B or both. I know one of them has to be, but they could both be. Based on that, we're going to say, okay, x plus 3 could be 0, and x plus 7 could also be 0. We're not quite sure. Now I have two equations to solve. If x plus 3 equals 0, I'd subtract 3 from both sides, and x equals negative 3. On the right, if x plus 7 equals 0, I'd subtract 7 from both sides, and x equals negative 7. These are my two roots or solutions or zeros, and if I wanted to double check on the other slide, I could verify that that's exactly where it hit the x-axis. If I were to substitute these solutions back in, negative 3 squared is 9, plus negative 30 plus 21 does indeed equal 0. If I substituted negative 7 back in, squared is 49, minus 70 plus 21, we get to 0. So I found my two solutions. Sometimes you might see it written, that's a bad bracket, you might see it written in those